Computer beginning. Hello, good morning, folks. Welcome to our circuitry class for 2nd and 3rd grade. This is the lesson 1 of 3 that we're starting here today. And our concepts for today are going to be circuit, diode, and battery. I haven't written the whole battery definition here for you guys, but we talk about a circuit with electricity. A circuit is a pathway through which electricity can flow. So what else are things that we use this word flow to describe? What else flows besides electricity? Do we have an answer to that? Yeah, what do you think? Mom
Pipe,
avatar.
pipes.
Pipes flow. What flows through them though?
Oh,
What
the
do we
water
describe?
flows through the pipes and they're
Right.
inside pipes. Mm-hmm.
Yeah, we talk about water flowing, and water flowing can do work for us. We can see water flowing, turning like water wheels or things like that. Have you guys ever seen anything like that?
Mm-hmm.
So flowing water can do work. We can also talk about electricity flowing and doing work for us. So a circuit is a pathway through which electricity can flow. We can talk, let me put that light back on. We can talk about having, say, a bunch of water in this area, in this spot right here, or a bunch of electricity, and then another over here where we have what? Just none, okay? And when we connect them, when we create a circuit like this, what happens is that the electricity will flow through here, right? That's our circuit. And when electricity flows, we can get it to do all kinds of work. Now, one of the things that we're going to have our flowing electricity go through and do is we're going to have it make light for us with a light emitting diode. Now, a diode
Mm-hmm.
is like a one-way gate, okay? A diode is a one-way gate, and electricity can only flow through that gate in one direction. See, I've made a little triangle there for you
Mm-hmm.
guys to sort of visualize that that's the direction electricity can flow. Now, if I did this and had all my electricity over here and none there, and it wants to flow this direction now, it actually won't, because it can't go through this one-way gate. See, the triangle points that way. So it's
Mm-hmm.
not going to go through that way. So a battery, what is a battery now? Whoop, I think I need a proper eraser for my whiteboard instead of paper towels here. Uh-oh. Yeah, that's pretty sloppy looking. I also need some spray. Anyway, a battery is essentially these two spaces. We bring them together. So a battery is basically a compartment, or rather a box with two compartments. We have a big wall right here in the
Mm-hmm.
middle, and nothing ever flows through that wall. That wall is a impenetrable barrier, okay? So we have our electricity on one side and then none on the other side. And then what we use a battery to do is we create a pathway through which the electricity can flow like that.
Mm-hmm.
And my arrows sort of show the direction that goes.
Mm-hmm.
So with our project today, we're going to cut over to another camera here in just a minute, and I'm going to show you what we're going to be working with here today, you guys. So let me move over here. I'm going to move my light. I'm going to switch my camera inputs to the project cam.
Mm-hmm.
How's that lighting? Let's turn off this desk light.
Mm-hmm.
Huh, I think it's clear enough without the desk light on. You guys like it?
It's pretty.
Got it. So we have our battery, these little coin cells right here. And if we look very closely at our battery, you probably can't see it on the camera there, but on this side of the battery, there's actually a little plus sign. So that plus is where all the electricity is. And then on the other side, this blank side that's sort of insulated with this black line, that's the other compartment of the battery where there's low electric charge. Okay,
Mm.
so when we connect things together, the electricity is going to flow out of this side of the battery, go around, and flow to the other side. That's our circuit that we're going to create today. So we're going to start with just a blank piece of paper. And with our paper, we're going to sort of draw out the pathway that we want our circuit to be. Okay, so my battery is right here. I'm going to put that in the corner. Let me move my extra paper out so you can kind of see this better. So with the battery there, I need to make it so that I touch both sides of the battery. Okay, so the way I'm going to do that is with my paper, I'm going to fold it over like
Mm.
this on the corner. Now when I do that, I'm going to draw a line here, basically showing that pathway, right?
Mm. Mm-hmm.
Whoop. I think I'm going to bring it in a little bit more, okay? Just give myself a little bit more space to work with.
Mm-hmm.
So I'm going to do that there. Then this is going to come out this way, okay? This is the pathway I'm going. I'm going to make a skip there just for now. And then the pathway is going to continue. And where does it need to go? It needs to touch the other side of the battery, right? So that's going to be just under it. There, right. So as I fold that over, that creates that pathway. Now I do have a break in the pathway right here. So this is not a complete circuit yet. There's not a continuous pathway. What I'm going to put in that spot is one of my lights. So I'm going to open up my
Mm.
kit here with my lights. I think I'm going to do that. As a, there we go. All right, so the red one. Now, there's my red light. Put this box aside. Now, remember that this light emitting diode is a one-way gate, and electricity is not going to flow both directions through it. In fact, what we see, if you look closely, is that the LED legs are different lengths. It's hard to see for you guys, but
Mm.
they're different lengths. One's longer than the other. There, that's maybe a little bit better. You can
Mm-hmm.
kind of see.
Mm.
So I'm going to put this directly on the battery this way. I'm going to touch one leg to one side and one leg to the other side, and that does not go on. Now, all I do here is I turn it around, and now that's going to go on.
Oh. Huh.
So because it's the right way, it goes through. But even though the circuit is complete, if it's the other way, it's not going to go through. So what I notice here is that the longer leg of the LED is the side that touches the plus side. So that's pretty easy to remember. Longer leg goes to the plus side of the battery, okay? So we're going to set our battery down here on our paper again and remind ourselves, what's the side for the plus? The side for the plus is the side that faces down on
Mm.
the paper. I'm going to go ahead and even mark that for us maybe to remind us, okay? And then the side that touches the minus over here, I'm going to mark that as well.
Uh-huh.
So that's going to be our pathway, and our light is going to go here. So we make sure that the longer leg is the leg that is on the plus side right there. I can even bend it a little better so that it just touches there. All right, now the next material we're going to work with is our copper tape. So this right here is pretty delicate stuff. It's easy to kind of get it to go all over the place. In fact, I have a few too many coils of it off here right now, but I'm going to go ahead and sort of measure out like this the segments that I'm going to put down. There's going to be one there. There's going to be one over here like
Mm-hmm.
this. And then, of course, there's going to be kind of a shorter one up here. I'm just sort of estimating. There we go. That seems fine. And then, of course, we have the ones that go here. That one and that one. I think I have one more. This one right here. So let's see how long we've made that. All right. So we can put our copper tape aside and work with our little segments here. I'm going to start with this one right here. And it's actually really difficult to get the backing of this tape off, you guys. So It does require a little bit of patience, and it helps if you have, you know, some nails. If you've just cut your nails and they're real short, maybe you'll have some problems. But I have good nails here, and this is taking me.
This is a place where moms can help,
Yeah,
maybe.
for sure. For sure. If you're doing a class like this with 30 kids, it definitely pays to have a helper at this point to help with this. So these are also very delicate. They want to curl up quite easily when you take the backing off. So you have to be quite careful and make sure that you go ahead and stick that down without it sort of curling everywhere.
Mm-hmm. And
So
it's
that,
adhesive on that side.
yeah, it's adhesive on that side. So that part is down. Now we're going to take this piece and we're going to go ahead and get that separated from there. There we go. And one thing that we want to be mindful of as we work with these materials is we want all of the tape to overlap other tape everywhere that we put an end down. Okay, so this right here is going to go down on my pathway that I've drawn. Now, if I were to take this tape here and just put it like that, whoop, maybe you can't see that. Maybe I should be drawing in yellow or green, something that gives good contrast against the copper.
Mm.
So if I just did that instead of, you know, this proper thing, I would have a break in my circuit. So you got to be careful that you're making sure these little joints are overlapping and connecting. So I'm going to go ahead and put this here. Now I can put these little spots down first and then attach the light to it with more tape, but I'm going to try to be a little bit efficient here. So remind myself again, the longer side. Which side is that? Whoop, that's this side right here. Goes that way. So I've bent the legs to be basically right on the line there, and I've stood the LED up, and now the tape goes over the leg, and then also over the joint there at the corner to hold it down. And I'm going to start with the leg over here instead of the long piece, just so I can get this LED down. Let me go ahead and get this other. There we go. Nope, not quite. All right. So that's peeled up from there. We're going to put that down on there. Now we have our longer piece to do along the bottom, and then our final one just to come up to the plus side. So our long one there. Uh-oh. Oh no. Emergency. Okay, wait. I think I can salvage this. It's stuck. There we go. Yeah. Just some. There we
You
go.
can see the difficulty if you're not real careful.
Yeah, for sure. And these tapes do come in quite large rolls. So even if you're not quite careful, you'll still have enough materials to do all three of our lessons here. All right, so the last piece here. Certainly if you're stocking a STEAM lab at home or at a school, it definitely pays to buy this stuff in bulk and not, you know, on a as you need it basis, because you can go through it pretty quickly, and when you buy it in bulk, you get it quite a lot cheaper. I know I paid like $12 for these 6 rolls instead of like, you know, $4 for one. So anyway, we have our pathway all laid out here, and the corner right there, our battery goes right there, and then when we
Ooh!
Yeah.
Wow!
Yay!
Pretty cool.
So our pathway is complete. So some of the ways, obviously, that this can go wrong is if our light is the wrong way in there, it's not going to work.
Mm-hmm.
Also, if our joints at these corners are not overlapping, then that's not going to work.
Uh-huh.
Another thing that can go wrong in here is if you don't have the legs um, under the tape. Maybe you're
Mm-hmm.
maybe you're just kind of like setting it down on top of the tape. They need to be under the tape
Mm-hmm.
to reliably work. So that's our circuit. That's our project here for today. And if you guys want to, you can make other types of circuits for other kind of cards for various holidays and maybe for someone's birthday. And
Ah,
yeah,
yeah, you can use that to. Is that how those cards work that have lights or sound in them?
yeah, absolutely. They'll open, and when they open in a particular way, it maybe like overlaps to kind of things like this to create
Mm-hmm.
the closed circuit. Because when it's not lit up and when it's not doing its thing, that circuit has a break in it, right? The circuit is open, or yeah, open. We say it's not a closed circuit. It's not a
Mm-hmm.
continuous pathway. But when you shut it in a particular way, it creates that closed circuit and the pathway completes.
Very cool. That looks like a lot of fun to me.
Yeah, it is a lot of fun. And then our next week's lesson 2, we talk about voltage, and voltage is basically the strength of the electricity and how you can you know measure that and understand things about that.
Mm.
So
Very cool. So,
excellent.
how? Tell me again about the work that the diode is doing. What is how is light like work?
How does light get generated by the
Yeah.
diode? Well, it's kind of like a well, the first kind of light bulbs we had were incandescent bulbs with a filament in them, right? And the
Mhm.
filament, when the electricity goes through it, it glows super hot and really bright, and that's how that creates light. Now the LED has a little bit kind of a different mechanism in it and a different material, but the principle is still the same. The electricity goes through the filament, essentially, for lack of a better word, within the LED and causes it to glow. And the great thing about the material that is the active part in there is that it's actually far more efficient at glowing and generating light. A incandescent bulb, its filament requires uh, quite a bit more electricity, quite a bit more voltage for it to produce the light. And these little LEDs, what we'll learn in our next lesson is that they require such a small amount of voltage to light them, so they're far more efficient.
So I have a mom question.
Yeah.
Is it dangerous to put your hands on the circuit and the battery?
Well, the electricity will flow where it can. So in this instance, the pathway that it flows is through the pathway that we've made. If you're talking about getting electrocuted, that's an instance where the pathway through your body is the pathway that it's flowing through. So a given pathway will have what's called resistance to it. Imagine there's a resisting force now against the electricity. Now, there's not a very high resistance to this pathway that we've created with our copper tape because
Mhm.
copper has a relatively low resistance. That's what makes it a good conductor. But the pathway of you touching the battery to the ground, that's a very high resistance pathway, and there's absolutely no chance that the electricity will flow out of it through you into the ground in that way. Some folks, um, uh, with a 9-volt battery, maybe you can get a little bit of a shock if you touch both heads, but that's only because the pathway is so short. It's through your finger, from one
Mhm.
head to the other. It's not going to go through your whole body. But sometimes people can get a little shock if you. There's no kids here now, but if you stick your tongue on a 9-volt, you get a little tickle because it does shock you there.
Yeah, well, we won't do that. But
Sure.
what is the voltage then on these small flat batteries?
These small flat batteries have a voltage of 3.7 volts when they're maximally charged. So a given AA battery, say, has 1.5 volts, so that's even weaker. So you've touched the end of a AA battery, and
Hmm.
that's not been a problem, I take it.
Show us again how the switch folded over the paper works to turn on the light, because that's just really cool.
Sure. So what we have now with the switch in this open state is we have a circuit that is open. It is not closed. There's not a pathway from one side of the battery to the other. Now I create that pathway and close that circuit by touching this point at the end of the tape here, right to the top of that battery. So when I do that, now the electricity can flow through that pathway. Whoop, I can't let it slide out. And then it goes there, through the light, doing its thing, and then through there.
That's very cool.
So that's just one light. Most of our gadgets aren't just a single light. We have a bunch of lights, a bunch of motors, all kinds of stuff. So in the next, in the final lesson, week 3, we'll talk about being able to power multiple devices and how you orient them in a circuit. And that's a lesson in current, which is basically how much is flowing at a given time.
Very cool. Thanks so much, Mr. Blake.
Sure. Thanks for being at our lesson here today.
That's a lot of fun. I can't wait to try it at home.
Great. Thanks. I'm going to go ahead and close the meeting here now, but you can check out any of my other content on the YouTube channel. The YouTube channel is called Mr. Blake STEM Instructor, and you can also search for my posts on Facebook under that same hashtag. Thanks very much. Have a good day.
Bye bye.
Bye-bye.